Okay, so this video is the overview for implicit differentiation. Now, this should be totally new, and let's not cut to the chase here. Let's do cut to the chase. This has got E-level stuff written over it, so don't let that put you off. But if you've been chugging away at the stuff, you know, previous stuff, and you're getting some merit questions correct, yeah, have a go at this. If you're going to be a calc student, then this is something you want to have uh, the understanding, the processes of what implicit differentiation is. And if it were presented in front of you, you could implicitly differentiate something, and it's a powerful tool to have. So sadly, however, from my search of the STEM Online, they have not done material for this yet as of May here when I'm making this video. So instead, Professor Dave explains, and he's quite funny, and yeah, pretty good. This here is a screenshot from slide 3, and I think it's a fantastic definition. Okay, so an explicit function is when y equals ta-da, ta-da, ta-da. You can happily differentiate those. If it was more complicated, quotient rule, exponentials, natural log, not a worry. But an implicit equation is yeah, not explicit, not y equals. So for example, and your challenge is, do you go to the trouble of trying to rearrange it to make y equals? Sometimes that's impossible. Okay, so if you can't do it, then you're stuck with having to implicitly differentiate. And the key to this is not being stressed by that. Yeah, so, and there's a subtlety which I'm hoping Professor Dave can explain to you, and if you can read it through here on the Tahi Maths website, possibly on a Wednesday BC session, for anyone interested. Hey, I'm pitching just half the class are going to be keen for this. What the heck? We'll have a go, okay? Do have a look at the two answers here. This is just a bit weird. Let's see what it looks like. Yeah, so this thing up here, xy plus y squared equals 8. And apparently you have to work out the tangent gradient that goes through the point 2, 2. And basically, yeah, how do you do that? So, how do you differentiate that and then plug in at x equals 2? And apparently the gradient is negative 1/3. You can sort of see that there, negative 1/3. Just another one. This one's probably a bit more abstract. This one here is, come on, that's weird. Okay, so what the heck's going on there? Okay, welcome to the wonderful world of conic sections and derivative implicit differentiation. So, possibly quite an interesting course. By the way, I've just noticed here Nancy Pye, bless her, has done a video on this, so well worth watching. For the Top Guns, this is a British website. And it's teacher's notes. So a circle, as you can see, is implicit. You could rearrange the circle, relatively straightforward. Put the x squared over there, square root both sides, and get plus and minus functions. Yeah, can you find the gradient at any point? And what we've got here is a geometric differentiation, and the bottom one here is implicit differentiation skill set. And so the challenge here is, hey, how do you do this by three various ways of doing it? So, and you might come to the conclusion that implicit differentiation is actually the easiest. Geometric differentiation, implicit approach, which is easier? Okay, and once you've cottoned on to the key skill set, how do you differentiate an expression like that with a y in it? Okay, you're away. Down the bottom here, this chap again, trying to look smart in calculus. Yeah, if you can do implicit differentiation, you're probably in that category. And there we have it, y squared. Look what happens here. So here's the skill. You actually apply a bit of chain rule. Now, what I've got here, what is wrong or missing with the diagram? By the way, that this algebra is good, but as you'll see if you go through it, something's missing. He hasn't the person who made this hasn't finished it off. We need to group all the dy by dx on one side and push it over there, the other stuff, and get a relationship. So he shouldn't be laughing yet. He hasn't quite finished off his algebra. Yeah. Okay, so that's all. Put that